In March 20th, 24, during a high-stakes teleconference with aviation industry leaders, Russian Defense Minister Sergey Shoigu received groundbreaking news. The Il-212, a state-of-the-art light military transport aircraft, was nearing completion. This new marvel, powered by advanced PD-8 jet engines, was set to replace the aging An-72 and An-26 fleets. This development wasn't just a routine upgrade, but a game-changer. The Il-212 promised to not only address the critical need of Russia's military aviation, but even shock the world. Here's why. But before that, to fully understand why this aircraft is so special, we need to know why it was built. In fact, the Il-212 is a significant redesign and improvement over the troubled Il-112V. It faced numerous challenges, including technical issues, delays, and a fatal accident. Initially intended to replace the aging Antonov An-26, the Il-112V's development was marred by design flaws, engine problems, and strategic setbacks. A failed collaboration with India further complicated the project, leaving Russia to continue development alone, which increased financial and logistical burdens. The Il-112V's reliance on problematic TV-7117S turboprop engines led to repeated reliability issues and delays. Despite completing its first flight in March 20th, 19, the aircraft continued to face stability problems. The most severe setback occurred in August 20th, 21, when a catastrophic engine failure during a training flight resulted in a crash that killed the crew. This incident led to the suspension of the Il-112V project and a comprehensive investigation, which highlighted significant design issues. Consequently, Russia decided to discontinue the Il-112V and develop the Il-212 to address these critical flaws. So the question here is, what exactly did Russian engineers take away from the setbacks of the Il-112V when crafting the new Il-212? The most critical lesson to learn is, of course, from the engines. The new Il-212 design moved away from turboprop engines, opting instead for PD-8 jet engines. Unlike the Klimov TV-7117S turboprop engines used on the Il-112V, which struggled with both power output and weight management, the PD-8 engines bring several advantages that make them a far superior choice for a versatile military transport. Firstly, the PD-8 engines, currently also in development for the Sukhoi Superjet and the Bereev B-200 amphibious aircraft, have been designed with modernized systems and materials that enhance reliability. The PD-8's technology allows for consistent performance and a lower likelihood of mechanical issues under the high-demand conditions that military aircraft frequently face. In contrast, the TV-7117S engines on the Il-112V often underperformed, requiring more maintenance and experiencing issues with power consistency, which added delays and costs throughout the Il-112V's troubled production. The PD-8's increased thrust is another key advantage. Each PD-8 engine provides roughly 8 tons of thrust, significantly outpacing the 3,170 kilograms thrust produced by a single TV-7117S engine. This greater thrust output translates into a higher payload capacity and better takeoff performance, even from short or unprepared runways, a critical requirement for military operations. The PD-8's jet-powered design means the Il-212 can operate at a cruise speed of 750 to 900 km per hour, far faster than the 500 to 650 km per hour range of the Il-112V, allowing it to cover long distances more efficiently. Moreover, the placement of the PD-8 engines above the wings serves a tactical purpose. By directing exhaust airflow over the wings, the PD-8 engines create additional lift, a feature especially advantageous for rough and unpaved runways where debris might damage traditional underwing engines. This design change greatly reduces the risk of foreign object damage and enhances the aircraft's versatility in challenging environments, including Arctic conditions where the Il-212 is expected to operate. Despite these advantages, the shift from turboprop to jet engines does come with trade-offs. The PD-8 engines are heavier, each with a nacelle weight of around 2,300 kilograms, compared to the lightweight TV-7117S engines, which weigh only 500 kilograms each. The increased weight necessitates a redesign of the Il-212's wings and central structure to balance the load and maintain structural integrity. However, the added weight is compensated by the PD-8's superior thrust, which improves the Il-212's performance even with the added structural demands. The PD-8 also consumes more fuel than the TV-7117S, a common drawback for turbofan engines over turboprops. However, the power and range benefits afforded by the PD-8 engines outweigh these fuel considerations in the context of military logistics, where mission speed, payload capacity, and reliability are critical. In short, the PD-8 jet engines not only enhance the IL-212's overall performance and reliability, but also give it the edge needed for military roles that the IL-112V struggled to fulfill. By making this strategic shift, Russian engineers aim to deliver a transport aircraft that can operate across diverse terrains, meet demanding mission profiles, and reliably replace the aging Soviet-era aircraft still in use today, aircraft better suited to military transport roles in a variety of terrains and conditions. But of course, the new engines alone aren't enough to make the IL-212 significantly more reliable than the IL-112V. Do you know what other improvements contribute to its enhanced reliability? Lessons learned from the IL-112V's shortcomings also led to some changes in the IL-212's design, especially in areas like structural durability and resilience in harsh environments. Notably, the IL-212 is designed to endure extreme climates, including sub-zero temperatures in Arctic regions where Russia's military operations are expanding. This durability marks a major enhancement as the IL-112V struggled to maintain reliability in severe conditions. One of the IL-212's key advantages is its extended operational range, which enables it to cover greater distances without refueling. This improvement is crucial for supporting remote military bases or executing long-range missions in areas like the Arctic, where airfields and refueling points are sparse. Additionally, the aircraft boasts an increased cargo capacity, enabling it to transport more troops, equipment, and supplies than the IL-112V. This enhancement aligns with Russia's objective to deploy an efficient, versatile transport aircraft that can fulfill a range of military needs, from supplying equipment to distant bases to quickly deploying personnel where needed. Another significant feature of the IL-212 is its capability to operate from unprepared airstrips, including rugged dirt or snow-covered runways. This capability is essential for missions in remote areas or conflict zones where well-maintained runways may not be available. The IL-212's design specifically includes features that allow for safer, more reliable landings on rough terrain. This flexibility aligns it with older Russian models like the An-26 and An-72, which were also designed for operations in undeveloped regions. By retaining this capability, the IL-212 enhances operational flexibility, enabling the Russian military to conduct missions in a broader range of environments. In terms of internal systems, the IL-212 includes redesigned fuel and hydraulic systems to improve performance and minimize maintenance issues encountered with the IL-112V. The updated fuel system is more efficient, extending operational endurance and simplifying refueling logistics, which is especially important for remote deployment scenarios. Likewise, the upgraded hydraulic system provides more stable and responsive control, enhancing safety during complex maneuvers and landings on uneven terrain. The IL-212 also features redesigned wings and landing gear. These modifications enhance the aircraft's aerodynamics, fuel efficiency, and structural durability, allowing it to carry heavier loads over long distances. The new wings are optimized to reduce drag and increase lift, which supports the aircraft's extended range. Meanwhile, the reinforced landing gear is designed to handle the impact of takeoffs and landings on rugged surfaces, improving resilience and reducing the likelihood of damage when operating from unprepared airstrips. This reinforcement ensures the IL-212 is ready for rapid redeployment, increasing its reliability for immediate or repeated missions in challenging environments. Together, these design improvements make the IL-212 a versatile and dependable addition to Russia's military transport fleet. With increased range, payload, and operational flexibility, as well as advanced systems and structural durability, the IL-212 represents a significant step forward in Russia's efforts to field a modern, reliable military transport aircraft capable of supporting a broad array of missions across varied and difficult terrains. So, having informed about all the improvements and updates of this new aircraft, what we really care right now is: how does the development of the IL-212 align with Russia's strategic goals, and what potential impact could it have on the global military transport market? Expected to achieve prototype production by 2026, the IL-212's development is being closely monitored domestically and internationally, especially for its ability to operate in the Arctic and other challenging conditions. This aircraft aligns with Russia's strategic goals of increasing its Arctic reach, asserting influence in remote areas, and reducing dependence on foreign technology by using locally produced components. If successful, the IL-212 will serve as a model of Russia's shift towards self-sufficiency in aerospace manufacturing, helping to strengthen its aviation industry, which has faced hurdles due to economic limitations and international sanctions. Beyond military applications, the IL-212's improved range, cargo capacity, and adaptability also make it suitable for civilian roles, such as regional transport and disaster relief, where reliable access to remote locations is critical. Internationally, the IL-212's progress is drawing interest, particularly from nations seeking a rugged, flexible transport solution without reliance on Western suppliers. Should it prove cost-effective and reliable, the IL-212 could offer an alternative to established models like the Lockheed C-130 Hercules and Airbus C-295, which dominate the global military transport market. Russia could find opportunities to supply this aircraft to countries with limited budgets, or those looking to diversify their suppliers, especially in Southeast Asia, the Middle East, and parts of South America and Africa. The potential success of the IL-212 could introduce a new competitive dynamic in the light transport aircraft market, shifting reliance away from Western manufacturers and toward a more diversified global marketplace. This trend might encourage other nations with emerging defense sectors to invest in indigenous military transport designs, fostering a more multipolar and varied military aviation industry in the years to come. And if you enjoy this content, don't forget to subscribe for more. Thanks for watching.